Okay, so I would not be the least bit surprised, even in a 45-minute shortened exam, that College Board floats something like this out to you, interpreting a scatter plot, maybe the computer printout. So let's take a look at this one. So interpret the slope of the least squares regression line. Biggest piece of that is the in context part, right? Don't miss that. Whatever your answer is here ought to be talking about number of wins and attendance per game as well. Okay. Explain why it's not reasonable to use the least squares regression line to predict the attendance per game for 0 wins. What's the value of the correlation of coefficient? And then a couple other layers to this. If the point representing 64 and 40,000 is removed, what would happen to the slope and to the correlation coefficient? So let's try to unpack each part of this. So just from a quick look, it looks like there's a weak or moderate positive linear association between number of wins and attendance per game. So that's how I want to talk in interpreting the slope. So the first thing, a big mistake that I'll see a lot of times is students will say that this is the slope. They get confused and they see S and like, well, that must be the slope. Okay. Remember how these equations work. When I look at the computer printout, I'm trying to predict attendance, right? That's my response variable. So I predict attendance, okay, based on wins. So the slope is the coefficient of the wins, okay? So we usually write the y-intercept first, so 10,834 plus 235 times wins, okay? So the interpretation of this slope, remember, it's about this line here. It's not about, so I don't want to say something like, for each additional win, attendance goes up 235. Goes up by 235, because that makes it sound like that's how these points are behaving. And this line is just doing its best to explain it. So make sure that this number 235 is talking about a rate of change in predicted attendance. So for each additional win, the attendance is predicted to increase by about 235. That's your interpretation of the slope. So the second question says, why should we not use this model to predict attendance for a team with 0 wins? Well, that's because this model was never intended to be used for a team with 0 wins, right? This model is only appropriate for teams with this many wins, 60 some, all the way up to 100 and some wins, okay? If we have anybody that has more wins than that, this model is no longer appropriate. We can only use a least squares regression line model for X values that are within the range that the model was created, right? These are, think about using shoe size of elementary school students to predict their reading level. That would probably work for elementary school students, but if then you go ahead and take it and try to use it for high school students over here, it wouldn't be helpful anymore, okay? So that's the idea. Okay, I think I might have got confused for a second there. I'm not sure if I recorded what would happen if we remove this point, but this is the point that they're talking about. All right, so right now with that point in there, remember the line is trying to make that square as small as possible. So if that point gets removed, the line doesn't have to be pulled towards it anymore. It would, on this end of it, drop down a little bit. That would make the slope increase. Right? This line then is this portion of the line is going to shift down, and the overall slope is going to be steeper. Okay? Because this point has a large residual, and we take it away, that's also going to make the correlation stronger. R is stronger. On your formula sheet, you should see an equation. The slope of the least squares line is the correlation coefficient R times standard deviation of Y over standard deviation of X. So we think about this relationship. If this number gets bigger, then R is naturally going to have to get bigger unless we change the standard deviation of Y and standard deviation of X. But if we remove that point, it should change the standard deviation of both of those. But I would expect for the slope to increase and for R to increase.